So it's a pleasure here to host AJ Kamar. She's a distinguished scientist, corporate vice president, and managing director of the AI Frontiers Lab at Microsoft Research. And releases from her lab include many models you might have heard of, include the Phi family of models, as well as AutoGen, Magentic 1, Magentic UI. She has more than a decade of experience studying the impact of AI in society, and she's been a huge force in building the responsible AI efforts inside Microsoft. So she has her PhD from Harvard University, and she's been working on human-AI collaboration and building on this since. She's also an affiliate faculty member at the University of Washington in the Computer Science and Engineering Department, and is an adjunct faculty at Sabanci University. She's also a member on the first study panel of Stanford's AI 100, and is currently serving on the National Academy's Computer Science and Telecommunications Board. So she's received multiple awards for her work, and I'm pleased to say that I had the pleasure of overlapping with her for a few years at Microsoft Research, and I'm thrilled to be hosting her here today. So please take it away.
Thank you, Grija. Hello, everybody. Can you hear me? Thank you for coming. This has been a wonderful visit so far. I had so many interesting conversations with some of you. So today I will try to discuss where we are in the AI space. And this is a difficult topic because the field is moving so fast, especially as somebody like me sitting in the industry space, to a point that I actually find myself never giving the same talk twice. Because every time I need to give a talk, there is something happening either in my lab or somewhere else that requires taking a different look at this talk. I gave this talk, I think, 2 weeks ago, and I had to update it already for you guys. So I will try to do 3 things today. Hopefully we can have a conversation at the end about what I'm talking about. The first thing I want to discuss is, again, where are we in terms of the impact of AI in the world today, and what is the work that needs to happen to move it forward. Then I'm going to present some of the work that my team has been doing around the agentic systems. And then finally, I'm going to try to make the case of why there needs to be more collaboration, especially with academics, especially in the multidisciplinary space, to address some of the issues I hope I will be able to motivate at this talk. So this is a given for this audience, that there are 3 factors that are driving the AI technologies today. One of them is the transformer architecture. The other is the large amount of data that is available on the internet and collected from people. And the third dimension is the very large scale of compute that is being used for training the models that are fueling the next generation of AI systems I'm going to be talking about today. In fact, one of the drivers of all of the recent advances has been this kind of a scaling curve, where on the X dimension, we are basically just seeing the timing of these earlier models that have been coming out. The Y dimension has been the number of parameters that has been going into these models. And at some point around 2022, 2023, what happened is that as these models scaled up and up, there was a factor of generalization in these models that made them a lot more interesting and made it a lot more possible to build interesting systems on top of these models. And in fact, sitting inside Microsoft Research, we gain early access to some of the models coming from OpenAI, and we spent some time looking into these models. And the question I'm interested in is never whether we are going to get to this undefined point of AGI or not. Of course, a lot of people would like to get that answer. But what I have been most interested in the last few years is thinking about these models as a general purpose technology that we can build on to create various different applications. And we are already seeing in the real world that there is high level of adoption of systems that are built on these large language models and large reasoning models. Just looking at, for example, the top applications that are being downloaded in the Apple Marketplace, the first 2 that you can see are Google Gemini and ChatGPT in terms of what people are most downloading. There's a third one about dating advice. I don't know. I still haven't time to look at what that is, but it sounds like an interesting one. In terms of the enterprise space, we are actually seeing that there is more than 80% adoption in some form of usage in enterprise context across the different enterprises that Microsoft works on. And one area that I'm getting a lot of interest in around Microsoft is the space of applying AI technologies for scientific endeavor, scientific discovery, hypothesis generation, and so forth. These are just some of the application areas that are either getting attention already or getting a lot of potential interest for creating really interesting impact in the world. One particular application area that is always very interesting for us to look at is the adoption of AI technologies in the domain of software engineering. And when we've done some studies, even 2 years ago, in terms of understanding the productivity impact of having these AI assistants in software development, what we have identified, I'm talking about systems that are much earlier than the ones you are probably using today. What we have measured is that among Microsoft developers that are adopting such technologies and the ones that are not adopting these technologies, the productivity can be as high as double in terms of the number of lines of code written if people are adopting such technologies. Again, I'm not saying that this is a generalizable result across different productivity domains. However, the fact that there is existence of such a productivity increase on a high expertise task is something that we have been watching very closely. So these are just some positive examples that I know many of you are aware of. At the same time, it is becoming clear this year that this transformation of this general purpose AI technology into the real world is not going to be a straightforward one. And in fact, this is creating a lot of tension in industry today because there is unprecedented amount of capital investment into AI technologies across the industry. And that is creating big expectations in terms of the monetary value that these technologies should be able to create and the revenue that they should be able to create. At the same time, we are seeing reports now, this one in particular from MIT is a really important one, that the real world adoption and the real world value from these technologies are not yet matching the expectations that industry have over these technologies. So in this particular report that came out last month, what this MIT report revealed is that more than 95% of the AI pilots in enterprises actually fail because they are not able to match the value proposition that these pilots have created for. And 95% of the time, these pilots never make their way into full-scale deployment. So the conclusion of this report, and I agree with this one, is that these results leave us at a point of Gen AI divide. There are big expectations about the return of investment these technologies should be having in the real world. And at the same time, the adoption, the real-world deployment of these technologies have been producing only incremental value, except for, I think, software engineering here is an exception.
How does this compare to just regular startups?
Regular startups?
Yeah, like just startups in tech. Like we know that most startups fail, right? So how does it compare to like non-AI startups like from 10 years ago?
So this is not, the 95% result is not a business creation result. It's take any well-known business where there are already existing processes and workflows, and they are creating some Gen AI integration into that existing business, and they are looking at the return of investment on that. And what they are finding is that 95% of the cases, this kind of an integration experiments are happening across enterprises. They are actually failing to return on the ROI side of what was expected before. So you are right that in the startup ecosystem, when people are creating new businesses, many of them fail. Maybe there is a parallel there. I find it interesting that on well-established businesses, the experiment of trying to produce value by AI integration is also failing. Yeah. Yeah.
Yeah, following up on that great question. So can you be more quantitative in what you mean by failure in that case? Because is it because we can also have unreasonable expectations and then it will never work? So what do you mean exactly by it is not meeting the expectations? So what is not working?
So I would encourage you to read the Gen AI report. It's available on the internet. Again, that's not going to be the main thing I'm going to be talking about today. But how they are measuring that in that particular paper is that they are going through enterprises and enterprises, looking at these projects, looking at what was the return of investment, like the value generation that was planned at the beginning of the project, and checking if they actually got to that level of return on investment on the project and whether the project actually got deployed in the organization afterwards or it was just canceled. So again, it is just a reflection on this point of Gen AI divide. I think we can ask ourselves a question of, let's take these LLMs and these technologies as some general purpose technology that can be implemented across different enterprise scenarios, consumer scenarios. We are actually seeing that this transformation is happening slowly than we expected. Have there been cases in the past in terms of applying or transforming enterprises with some general purpose technology? And are there lessons learned from those past transformations that we can apply to where AI is today? So this is just some reading I have been doing on this topic. I'm not a historian, but a lot of historians have written in terms of previous experiences like this. And one of the analogies people talk about in this space as an example of a general purpose technology that transformed enterprises in the past is the shift from steam engine to electrical engine in enterprises. And there are a few things that are interesting from that transformation when enterprises were doing that kind of a switch. One of them is that although the technology was available, the transformation of enterprises with that technology took decades, and many early experiments failed, which we can already feel that there are some interesting parallels there. And the issue is that I don't think the industries that we are working on are going to have that kind of a decades of patience in terms of getting that value of investment. So the question is, are there lessons learned from the past transformations that may apply to where we are in generative AI space today? So I want to talk about two lessons that I believe is a good fit for where the AI technologies are today. One of them is that we have all of these human processes today in enterprises and consumers. In many ways, how these technologies enter to our lives today is very incremental. We are creating these chatbots. We are not spending time thinking about how to best integrate these technologies into our lives. We are just kind of attaching to them. And we are expecting that just attaching these technologies as chatbots on the side is going to be able to create some transformational value, and that is not happening. So there is a lesson here in terms of how we actually take different domains, think carefully about the human processes, how humans are solving those problems, and do the work of carefully integrating and rethinking and redesigning those human processes with AI at the center. And I know many of you will resonate with this point because I had many conversations today about like how to make AI work in the different domains that you are working on today. And the second lesson from the past is about complementary innovation. When GPT-4 first came out, there was an expectation that just prompting these models and building applications that way was going to be enough. 3 years later, we are learning that that is not enough. We actually have many problems right now around memory and reliability and safety. And the only way we are going to be able to create resilient, powerful applications is bringing innovation across our computer science fields and beyond on top of this general technology of LLM stack and be able to innovate around it to be able to solve the fundamental problems we have in this stack today. So I made this point today or earlier, but again, if we are looking into how we are using many of the AI technologies today, we are using them in the form of chatbots. And I would claim that having these separate chatbots, completely separate from an understanding of what we are trying to do in the real world, is an incremental way of integrating these technologies into our lives. And therefore, it is very natural that we are only seeing some incremental benefit, but not necessarily that transformational benefit we are hoping to get. And one way to think about AI in more transformational ways is actually what my lab has been working on in the last 2 years, and that is moving the conversation from chatbots to AI agents. I'm not saying AI agents is the only transformational thing we can do, or it may not be even that the maximum transformation we can get, but thinking about where we started in the chatbots, agents provide a number of directions where it is much more transformational as a fundamental technology than the chatbot. So what is an AI agent? An AI agent is a computational entity that is able to take a complex task and be able to accomplish the task by perceiving the world, deciding what to do in it, and acting in the world, and complete this feedback loop with the world. So why agents are more transformational than chatbots? Because with chatbots can only tell us what to do, and agents could actually do the action on our behalf or with us. And the purpose of an agent is around task completion, not only having a conversation. The other reason that AI agents are more transformational is that because they can be embedded in the world that we live in, they can perceive the world, they can act in the world that we live in, and therefore there is a better integration point of these agents into the human workflows and processes. And one thing to mention here is that the topic of AI agents is not by any means a new research topic. In fact, 20 years ago when I was doing my PhD work was about AI agents and multi-agent systems. However, there is a lot of now value of taking these ideas that many people have worked on for decades and thinking about their applicability to the new computational stack that is emerging from these large language models. As I mentioned before, I watch the domain of software engineering very closely because that's kind of almost like a canary in a coal mine scenario for AI adoption in the world. And we have been observing that with Cloud agents and many other agents form, a lot of the adoption of AI in the software agents is transforming from more of the chatbot mode to the agentic mode. And there are a lot of anecdotal evidence of the value that people get from having these agents that are actually driving the workflow with people rather than an agent that is only able to do the next word completion.
On the agents, like from what I know, we usually give them tools on the way that they're supposed to act and like how they can do things. How do you test the possibilities of what they can do and make sure that they don't do something they shouldn't do, or like exploit a tool that they're given in a wrong way?
I'm gonna get to that. When I get to that, let me explain you the work we are doing, and then we can have this conversation. But a great point. So in my lab, we have been very much thinking about the new computational stack that is emerging to be able to power AI agents. So in this talk, I will mention the work we are doing on 3 layers of the stack. So the one layer is the models that we need to be able to power the agentic systems. And this is just an example of some of the releases that we have done across the stack. But then we are also learning that just building the models is not enough because we need that complementary technologies around the models to be able to build agents in a reliable way. And that's why we've been also building the layer of agentic orchestration, which relates to the work on multi-agent systems. But again, having just these AI systems being able to solve problems is not enough, especially due to the reliability and safety issues that we have with these agents today. And therefore, it is also very important that we are building this human AI layer that comes on top of these agents so that humans are able to understand what these agents are doing, they are able to intervene and guide the agents, and they can stop the agents if the agents are doing something that is not safe at the moment. And that's why we have been working across the stack in my lab. So let me start by talking about what we've been doing. Again, this is going to be a very quick overview. I encourage you to look at the individual releases and the papers to learn more, and I'm happy to answer questions. But I'm just saying that this is going to be a very fast overview because we don't have a lot of time. So first, looking at the human agent layer. The particular domain that we have been focusing on lately is this domain of computer use agents. So in these applications, what we are trying to build are computer agents that are able to carry out tasks on a computer like this by interacting with the computer the way a human interacts with the computer. So this includes being able to go to websites, navigate the internet, fill in text forms, being able to click on things, and by doing this, being able to carry out tasks. It is not like people need so much help with carrying out these tasks, but it becomes a good end-to-end way of testing where we are in terms of the agentic capabilities. So what I'm going to be showing you here is the release we've done around Magentic UI. This is a general AI agent that you can interact through a chat interface and give tasks to it. But the agent will not only stop with this interface. What it's going to do once it gets the task is that it's going to create a screen where it's going to be able to collaborate with the people in terms of creating the right plan for doing the task. And here what you're seeing is that the person is able to reflect on the plan, edit the plan, add steps, remove steps to come up with the plan. The other thing you can do here is actually take control from the agent through a transparency screen where you're able to see at any point in time what the agent is doing, and take control over when the agent is not doing the right thing. And the other thing that the agent is doing is when it is going to be taking an action that is irreversible in the world, for example, purchasing a product, it's going to actually stop and wait for human confirmation before it moves on. So the reason I'm showing Magentic UI is because we have implemented here and experimented with a bunch of human-in-the-loop techniques, from planning to execution to transfer of power between a human and AI agent, to be able to really test what are the mechanisms for a human to be aware of the agentic work, being able to intervene, and being able to be accountable and have the control, informed control over the agentic behavior as the agent is interacting. And we have released Magentic UI in open source so that if any one of you is interested in experimenting with these ideas, you can download it. Instead of kind of building all of the scaffolding we had to build around Magentic UI, you can just download it and build your own experiment around the agent-human feedback loop. Here I want to take a second to talk about why Magentic UI is an important research artifact for the kind of work we are doing in my lab. And there are three particular reasons for that. The first reason is the importance of end-to-end experimentation when it comes to agentic systems today. As you know, when people are building models, right, there are certain benchmarks that you can evaluate how good your model works. It gives you an idea of some statistical measure of how things are working. But given that AI is entering our world in so vivid ways, having an end-to-end application like Magentic UI, or one on education or one on healthcare, really give the semantics to these systems in terms of how they are working in the world, and give insights to my teams from modeling all the way to orchestration and experiences in terms of what are the things these things are doing really well, and what are the gaps we still have in terms of building these systems. Second, we get to have an idea of what is the work remaining for creating these agents. And I'm going to be showing later that by having Magentic UI as a test bed, we are actually collect a lot of instances of security and reliability errors that exist with these kind of agents that can influence further thinking in terms of mitigations that we should be building in these systems. And third, I really, really believe that it is going to, I'm going to get to this at the end of the talk, but we are at a point, especially with these AI agents, that there are so many open problems, from responsible AI all the way to the future systems we are going to be designing, that HCI, the human aspect, is going to be such an important question we need to get right in terms of putting these systems into the world. Just building the models, just focusing on the machine learning side is not going to be enough. And we need mechanisms to be able to bring these additional expertise together, HCI, AI, systems, formal proofs, verification, into the same language so that we can experiment together and learn together. And open sourcing Magentic UI is a simple contribution we are trying to do so that these worlds can get closer together and start working together. So let me get into the next layer of the stack, which is about agentic orchestration. When we started our journey of building these kind of agents, of course, like many groups, the first thing we tried was take an LLM, give it a prompt, and try to see if just prompting an LLM is going to create an agent that can solve many different things. Quickly, we've learned that that wasn't a very good programming paradigm when it came to building agents that could do complex things. And that got us into some reading around the notion of society mind, which was a term that was coined by Marvin Minsky in the 1980s, which was really talking about if you want to solve a complex task, one way to approach that would be actually using a multi-agent perspective. Take the problem, decompose it into pieces, create specialized agents that are good at solving different parts of it, bring that team together, and that would be a programming paradigm to be able to solve more sophisticated tasks. And that is something we started exploring with a library we created called Autogen. So we released Autogen around 2 years ago, and this provided developers and researchers a very simple interface to create multi-agent variants of the AI systems. And to our surprise, this became one of the most widely used tools at the time in terms of building multi-agent systems. And we actually ended up shipping Autogen to our product groups because they were so interested in making it part of the agentic stack at Microsoft. And I think a month ago, it was actually released as an official product inside the Microsoft stack, which wasn't our intention, starting the work on Autogen. And what were the things that Autogen was built on in terms of its key concepts? Again, if you're trying to solve a complex problem, divide it into simpler pieces. Understand the capabilities that are needed in solving those pieces. Create specialized agents that are good at doing them. And use conversation as the interface for collaboration. Those were the simple ideas that Autogen was built on, and probably the simplicity helped to make it a popular one. So earlier this year, we took these principles to create a generalist multi-agent team to power UI applications like Magentic UI, and we called this generalist team Magentic One. And we took two ideas to make Magentic One happen. One is, again, what we learned from the Autogen experiment. If you are trying to master a domain like computer use, think a lot about what are the capabilities needed to master that domain and build specialized agents for those capabilities. So for the domain of computer use, those specialized capabilities turn out to be having a coder, because in many cases you actually need to write code to be able to carry out pieces of the tasks. A file surfer, because in many cases you need to manipulate files in your computer to do these tasks. A web surfer, mainly because you get a lot of things done on a computer by interacting with the internet. An executor that's able to execute some of the scripts that will need to be executed. And finally, an orchestrator that's able to manage the team. And this decoupling of capabilities and bringing them together through the conversational orchestration that was the beginning of Autogen became one of the ingredients of creating this team. The second insight that Magentic One happened was that the orchestration of such a team actually required meta-reasoning capabilities that is not possible with the LLMs of today. So in many times, creating such a team and let them execute would get stuck, because they would try something and they would try it again and again and again, or they wouldn't know that doing something in one certain way is not working, and they would need to think about the problem in a different way. So the way we solve that meta-reasoning problem is actually designing a task ledger at a meta-reasoning step over the team that is able to keep track of the successes and the failures and being able to stop these agents to do things that are not working. And again, just like Magentic UI, Magentic One is available in open source so that any one of you can use this team for your research as well. So the third pillar here that I'm going to be talking about next is actually the work we are doing on models. Because going back to the idea of specialization and how once we understand certain capabilities, we can actually create specialized agents for them, we can use that insight to specialize models for those specialized agents as well. If you know what capability you are looking for, you don't need to go to a frontier general model to get that capability. You can actually take a small language model and specialize that small language model for that capability and gain a lot of efficiency. So just last week, we have released FARA 7B as our first agentic model to contribute into the stack. So FARA is a 7 billion parameter model, again, part available for open source, part of Hugging Face, that is able to do the combination of the orchestrator and the web surfer as a 7 billion parameter model that can actually be hosted on your device instead of going to the cloud. And because it is so small, it also means that you can get things done on your computer much faster than running a frontier model. And this FARA 7B is a continuation of the work we've been already doing in the small language model space. So the work on small language models in my team started with the 5 family of models. This is all the 5 family of models that have been created and shipped up to date by my team and our collaborators. A few things to mention here is that we have been shipping models that are on a spectrum of efficiency. So there are 1 billion parameter models, 3B, 7B, because different applications actually have different constraints in terms of the memory and the compute that you are going to have access to. And also, 6 months ago, we have actually applied the phi recipe to reasoning models and show that the small model distillation is not only applicable to language models, but it's also applicable to reasoning models as well. So these are all models that are available as part of Hugging Face family. Just as a note here, our journey on small language models actually started with this very simple paper from Ronan and Yuanzi, where they started this investigation with a very simple research question. They asked the question of whether scale is a necessity for intelligence in these language models. And the question they asked, because they are both parents, they asked the question of what is the smallest size of a model we can train to understand English language at a level of a 5-year-old kid. And this investigation gave us a proof point that you could have a model that was as small as 100 million parameters that could understand English language at its basic level. And with Sebastian Bubak and collaborators, we have built on this idea, created the first phi model, and wrote the paper of textbooks are all you need, to really discuss the value of instructional data as a way to be able to distill large models into small ones. And this has been kind of what have been driving our work on small language models, small reasoning models, and now small agentic models as well. Going back to the FARA model, how does FARA work? FARA's input is a task that comes from a user. It could be booking a flight or booking a ticket or purchasing something from Amazon. And basically what FARA does is it completes the simple agentic loop on your computer. So it perceives the context by getting the screenshots and the action history of what has happened on your computer already. FARA 7B is able to decide what is the next best action that takes us closer to our goal, execute the action on our browser environment, and continues this loop until the task is achieved. And just seeing, let's see if this video runs, it gave us some trouble earlier in the day. But okay, what you're going to see here is FARA in action, where we are going to be asking FARA to buy a gift from Amazon. And the first thing FARA is going to do is actually go to the Amazon website, so as a potential place that is able to accomplish this goal. So now it's on Amazon. It's going to be actually doing a query for instructional STEM toys for a 4-year-old child. And what you're seeing on the left is that all of the little actions that the model is taking to get to the goal of purchasing this toy for a 4-year-old child. And the actions are at the basic level. It is basically telling what is the particular pixel that the model should be clicking to be able to get to the next step of the goal. So here it is finding one toy that fits to the requirement, and then it's going to be actually adding that to the shopping cart. And what's going to do is that before it actually proceeds, it has learned through training that, again, this is an action that is not possible to take back, and it should be actually stopping and waiting for user verification before it actually completes the purchase. This is just an example of an agentic model now that's able to really take all of those agents that we have and being able to do it efficiently on our stack. So just a few notes about what it took to build FARA as a model that can work this way. So there are 3 important steps. The first one is data generation. Just like the textbooks are all you need paper showed back in the day, the key to training any model is high quality data that is a good representation of the domain. And to be able to do this for the agents we are building today, we actually had to create our own multi-agent data simulation pipeline that is able to take these complex tasks as input and be able to simulate a multi-agent orchestration to be able to collect traces of what doing this task looks like. And like AutoGen, we actually shipped this agentic data pipeline, the synthetic data generation pipeline, as part of Azure, I think a month ago. So it's kind of interesting how many of these research projects are now finding real use cases in the company. Once we have these synthetic data traces, then we distill them into a small model. And that distillation actually requires a combination of SFT and RL steps together. And there are interesting learnings we had that you can find in the technical report of FARA 7B in terms of the particular recipe and the sequences that worked in our experience in terms of being able to sequence SFT and RL. And finally, I want to emphasize that being able to have an endpoint where we can test FARA 7B, which is Magentic UI, having a team that is going all the way from synthetic data generation to model building to these experiences is actually giving us a lot of insights to do these models in the right way. And I want to again mention the kind of the multidisciplinary collaboration and the importance of that in terms of making FARA 7B happen. This is just some details in terms of the data simulation pipeline we have created. It was interesting that the first thing we tried was going to some of the data factories like Scale AI and trying to purchase this data. The kind of the cost they gave us in terms of 150,000 trajectories was multiple millions of dollars. And by creating our own multi-agent pipeline, we could actually do this for less than $1 per trajectory. So that was kind of also validated the idea of like why multi-agent simulation is such an important data source for creating such models. This is showing FARA 7B and comparing it with some of the competitor models like GPT-4o on the dimensions of accuracy and cost per task. Because as you know, the frontier models can be a lot more costlier to run. This doesn't only mean in terms of the computational cost, but also how long it takes to run these models. Because as we are building these interactive experiences, you don't want the user to be looking at a computer screen for minutes before they can see what the agent is going to be doing next. So that speed is actually very important. So the purple line here is FARA 7B. What you can see here is that for the different iterations of the model we had, we can actually climb really fast on this accuracy and efficiency curve, and which puts us into a really good spot with respect to like getting the performance of a frontier model, but not paying the cost of such. And again, this figure is available on our technical report. So I want to come back to your question about what we are observing with respect to the responsible AI risks when we are working on these agentic systems. As Grija mentioned, I spent many years inside Microsoft in building responsible AI practices, organizations, processes over the years. And Microsoft was probably the biggest, first big tech company that released these responsible AI principles as early as, I believe, 2016. However, what we are really observing is that AI agents, having these autonomous AI agents in the world, is really changing the risk surface when it comes to having these AI systems in the world. So why AI agents are changing the risk surface? One, the agents are about getting things done in the world. It's not only about producing the tokens, which means when they do something wrong, when they do something unsafe, it is actually changing the state of the world. It is doing something on your computer. It is buying the wrong product. It is actually deleting a file on your computer, right? The other thing we are observing is that as the models are getting more powerful, particularly with the integration of reasoning models as the orchestrators, agents are getting super creative in terms of getting things done, and they are not giving up. And that creativeness in terms of how getting things done is really breaking the operational boundary mental model we have around these agents, and I'm going to give you some examples on that. And finally, as you mentioned, now when we are talking about these agents, their action spaces is so large, because not only that they can write code, they can do things on your computer, they can click on things, they can buy things, but they can also call tools and other agents to be able to do things, which mainly means that their action space is unbounded, which means that their risk surface is pretty unbounded. So let me give a few examples of the things we have tested with Magentic UI and Magentic One in terms of how bad things can get. So the other day, I gave Magentic UI a very simple task. I said, can you go to a New York Times website and complete the crossword puzzle on New York Times? So like the examples you've seen, the agent knew where to go to. It went to Google, found the New York Times website, click on that link, got to the New York Times site. When it got there, though, it realized that there was a paywall. It asked for my credentials to get to the New York Times website. It didn't know my credentials. But it has access to my email. And through the reasoning models it's powered with, it could actually reflect that there's another way of accomplishing this task, which is clicking that other link that says you can reset the password. So it clicked on that and went ahead with the steps of changing my password. That's not the only tricky case we are seeing with these agents. We are also seeing that the agents are trying to write emails to the government because they need to find some document that is no longer available, but they are reading that. There's a government mandate that they can write an email and ask for that document from the government itself. When they need to do something that they are not capable of, they are reflecting that they can go to Amazon Mechanical Turk and hire a person. Again, I'm giving these just examples. Yes?
Why is this a surprise, though? I don't understand why it's a surprise. As soon as you give an agent access to your email, you're asking for all this to happen. So I guess I'm a little puzzled as to why this is like a surprise, this sort of behavior, the danger.
It may not be a surprise. At the same time, I think it broke my personal mental model when it did that.
I mean, as a computer scientist, the first thing you were ever taught was never, ever, ever share your password with someone else, right?
But I didn't share my password.
Well, it has access to your email, which is equivalent, right?
In some ways, yes. But again, I think the point I'm trying to make here, you might be right that it is obvious that these things would happen. However, enumerating all of these failure cases right now is becoming so hard. And when, as a user, and I think I'm a more informed user than a regular user, I was giving a task that I thought was so simple as completing a crossword puzzle, I never thought that one way to get to that answer would be resetting my password. And I find that surprising. But you're right, it has all of the tools to make that happen. I agree with you on that. So I don't have answers for you in terms of how to prevent these things happen, but this is basically just a call to say these things are going to be happening very soon in large scale. And there are interesting questions around the approaches we should be building into the human in the loop aspect, the safety aspect, the security aspect, the verifiability aspect, so that users like me who is not able to think about all of the negative sides are not being affected by all the risks that may happen in the space. So in the remaining 5 minutes, I want to mention a new area that we are exploring. And we are adding one more layer into this agentic stack these days, and that's the thinking around agent ecosystems. So I already kind of talked about the transition from single monolithic agents to society of agents, where we are using multi-agent orchestration as a way of powering more systems. And through our experience with Autogen, we've actually worked with many different enterprises, the open source ecosystem, to observe what are some of the characteristics of multi-agent systems these people are building these days. And we've observed a number of interesting things. We've observed that no longer that this multi-agent orchestration is becoming just a throwaway tool to get more done, but many enterprises are creating specialized agents to be persistent members of their workforce. And now what we are seeing is that many of these agents are being shared through protocols like MCPU and A2A. And these agents are starting to talk to each other and work across information boundaries today. These observations to us indicate that there is going to be another shift happening. So there was the shift of single agents to a multi-agent phenomenon. And we expect the next transformation is going to be a notion we are calling society of agents. People are calling different names to this. But we are going to be in a world where agents created by different entities are going to be able to collaborate, negotiate, and work together to be able to carry out more fundamental activities for our society. So the question I want to ask at the end of my talk is, what can we do to shape up this new ecosystem in the right level? Going back to the beginning of my talk, we talked about AI as a general purpose technology, right? And what is being built by this general purpose technology. Like in the past, there are a few things we have observed with such fundamental technology shifts. There was the internet, there was the social media. First, there was the technology. Then people figured out cool things to do with it. And what came next was ecosystems and monetization. When social media came out, or the internet came out, or search engines came out, with each one at the beginning, we didn't know how the companies were going to monetize these things. But soon enough, some big corporation found a way of monetizing this, and it created a power structure and a social dynamic that influenced our world in a very significant way. We expect that that's going to happen again now with AI agents. We are already seeing early examples of this. We have seen the announcement that OpenAI is integrating some agents, third-party agents, into the ChatGPT to be able to complete purchases. We don't yet know what this ecosystem and marketplaces and economic models and power structures are going to look like, but we know that they are going to be happening in the next year or so. And how we design them in a way that maximizes benefits for all and being inclusive for the world we live in is going to have significant consequences. So the one particular space we have been already experimenting with is commerce and marketplaces. So what is happening today, like there's a market, there are buyers, there are sellers. We are seeing that both sides of this marketplace is now being embedded by agents. The users have access to Gemini, the ChatGPTs of the world. The sellers are creating their own custom agents to become the interface to those chatbots. We are experimenting that there are different ways that even this kind of a marketplace can evolve into. One possible feature is something we call a walled garden, where both sides of this marketplace is being controlled by a centralized entity. This entity decides who is going to be in, who is going to be out, they are going to be getting their cut in terms of all of the purchases that will be happening. The other model is going to be potentially an open two-sided agentic marketplace where it works more like the internet. Anybody can be a participant here. Again, I'm not going to dive into all of the challenges and the benefits we are going to have in these two possible worlds. But the point I would like to make here is that these things are going to be shaping up really fast because there is a push for monetization. And we need interdisciplinary research economists, computer scientists, social scientists, really thinking about what this world is going to look like so that we have time to influence the decisions that are going to be taken in terms of how these marketplaces are going to evolve. A month ago, we have released something called Magentic Marketplace as a simulation and experimental platform for these two-sided marketplaces. Again, you can download it. It's available on GitHub. And the particular purpose of this is playing with some of the ideas that we are already seeing bubbling up from a scientific perspective. What you can really do in this marketplace is start asking questions like, create a marketplace. Is that maximizing social welfare? What are the different kind of biases that may be embedded into these marketplaces today? Do the agents are they showing systematic biases for some type of agents other than others? And are there ways that these marketplaces can include malicious entities that push for collusion or other kind of strategic behavior that may actually affect the social welfare? And the reason we released the Magentic Marketplace is because we believe it's very important that we have hands-on evidence in terms of the different issues that are going to be happening in these marketplaces. And there's so much work to be done, especially for the students in the room that are looking for research problems to work on. As these marketplaces are shaping up, there is so much interesting thoughts that we can work on in terms of defining what these marketplaces are going to look like next. What we have right now in these agentic spaces is there are some communication protocols, there are some payment protocols, but we are lacking the behavior protocols. What are the ways that these agents actually should behave in these ecosystems? We are seeing that collaboration skills of existing agents are very poor. What are the collaboration protocols for them? And finally, the last one, this is a long list, but what are the regulation governance that need to be implemented on these markets and other economic models so that we actually prevent some of the negative consequences that might happen? So again, just as a final thought, for the students in the room, there are so many open research questions in this space that are just looking for your brains to work on. Again, the fundamental issue we have with all of the agents we are building is that they are not reliable, they are not safe. When we give any of these agents out to people, we don't know if it's going to work or not, or what are the different things it can do. So it feels like there needs to be some fundamental breakthrough that we need to implement to be able to make these agents has guaranteeable correctness of their behavior in the world. For these agents to have a lot more value for users, we need to figure out how to have agents that are solving long-running and proactive tasks. What are the guardrails, controls, and human oversight that needs to be built over these agents? And I think we've already discussed all of the thinking that needs to happen over the ecosystems. So again, it is just a call for multidisciplinary research to start focusing on these problems and working together. At the same time, I really believe it's a time where we are having the societal transformation, and the work that will be happening here is going to be very consequential. So I'll stop there. I'm happy to chat afterwards. I know I've exceeded the time that Grija gave me, but I'm happy to chat after the talk as well. Thank you very much.
Yeah, thank you. I think we have the room for a little bit, so if there's a couple of burning questions, maybe one, we can take them.
Thank you for the talk. So at the end, you were talking about agentic interaction, but the example you gave of Amazon orders already has some interaction with like an AI and an algorithm that somehow responds to the action that the AI makes. So I guess my thinking is like, oh, if you look at certain products, you might be advertised those products more by Amazon. I guess, do you have any thoughts about how maybe this AI and algorithmic interaction may function in these different spaces and how this relates to like agentic, maybe like
Yeah, thank you for that question. I think the one key ingredient that we haven't discussed today around these agents is going to be the notion of memory. So one of the key problems that a lot of these frontier labs building these chatbots are creating today is both short-term memory and long-term memory for these agents to be able to remember previous asks and previous interactions and preferences. So if that capability comes through, we are going to be in a world where these agents that are going to be controlling our purchases, our service needs, kind of being these mediators for us, they are going to be able to customize these purchases and these asks, make them so personalized in a way that was never possible before. That could be a great thing, because then I don't need to go to Amazon and look at the different 100 toys that my kid may like, because the agent may just know. But I'm also concerned about what is that power is going to look like to convince me to buy something that I'm not interested in purchasing. I'm talking to people now that are spending many hours a day talking to these chatbots. There is a different kind of a connection that's being created. So the connection of that memory and revenue and monetization, I think, is something that we need to be thinking very hard about.
Thank you.
Thank you again for the wonderful talk. Building on the previous question, if we are entering a world where we interact with the information on the internet increasingly through agents who take a lot of the interactions off our hands, do you believe that the structure of the internet and the design of interfaces of how we interact with web pages and everything will change? And how do you think that information will be restructured or readapted for a future where it's optimized for agentic interaction rather than human interaction?
Yeah, great question. So we are now talking about like imagining a future, right, where the agent is going to be spoon-feeding information to us for us to read, let's say. As you know, the whole internet model of monetization right now is built based on the attention economy. Basically, people create content because they can insert ads into those websites in addition to the content. And when we are reading the content, we are also being exposed to the ad. And that way, there is an economic model there that promotes the creation of new and interesting content for us to read. So one obvious thing that may happen here is that if the agent is going to be extracting that information from a website and presenting that to us, there is no longer an economical model for a content provider to create that content. Then what is the incentive for them to put high-quality content forward? I think that's one. Like, I think we have to start imagining these worlds, because I think the world is going to look very significantly different in a number of years in terms of how we are consuming the information, how we are purchasing things. Again, this is going to invalidate some of the economical models we know right now on the internet. It's going to create new ones. This is just one possible thing that may get invalidated, but I'm sure if we put our minds together, we can come up with many different hypotheses as well.
Awesome, thank you.
And then there's a question about manipulation and misinformation here that's possible that I'm not going to even get to right now.
I think the last question is from
Going back to the point you made about memory, are there, like, I guess, what are some techniques people are trying to develop or pursue right now to increase memory for agents? Like, would it be, I don't know, connecting them to some sort of database? Would it be allowing them to, like, cache previous results to queries? Or would it be, like, allowing them to physically change the underlying neural network that's running them?
Yeah, great question. So when people are working on memory, there are different types of memory that they are working on. One very obvious one is the short-term memory, which is, let's say, a reasoning model is running to be able to solve a problem. The context that it is generating and it needs to condition on is just exploding in time. And this context is also getting very large as it's doing the tool calling, because every tool calling adds to that memory as well. And this is becoming one of the technical barriers from having agents that can run for a long time, because at some point you run out of memory. One of the ways we are looking into with the existing architectures like transformers is have an explicit action that reasoning models can call that basically says, summarize everything you know so far. Kind of a read-write action that you can teach to a reasoning model. We are experimenting to see if this is going to be a viable path. John Langford from my team is also looking into, like, are there new architectures? Like, are there extensions of transformers that inherently have a memory component in it that might actually keep like a constant size memory as these agents are running? I think it's a space that we are going to be seeing a lot of innovation. There is also the part of memory which is more of a long-term memory. Imagine there are all of these interactions you have with a chatbot. You are having a next interaction. What is the mechanism to be able to pull in the most relevant part or parts of the interactions you had in the last many years? That is more like a database retrieval kind of a question. What people are doing right now is write things, as you suggested, into a database and be able to retrieve it. Depending, there are some libraries MSR has created around GraphRag, for example, that have been used for this purpose. Again, it's a space I think that's very open for innovation that people are going to figure out. And there's a third part of a memory, which is like a user modeling approach. If you are the user, what are the things that you are very much interested in? Do you have particular preferences that we have identified about you that makes you happier or less happy, less satisfied about the service you are getting? I think that's kind of another part of memory that is more around personalization that people are also thinking very much about right now.
Thank you.
Thank you. Let's thank AJ again for a wonderful talk, and we'll conclude.